So next up on our agenda is branches. So we've sort of completed the flow through the whole pipeline. We'll jump back a little bit now and deal with branch instructions. So at this point you should be able to see your program executing the first couple instructions correctly in our program until we get to that branch. And now we're going to add the support for the branch, at which point we'll be able to actually see the loop iterating and accumulating the count that we're keeping track of. So first thing we're going to do here, branch instructions, the terminology that RISC-V uses, branches are all conditional branches, which means we will take the branch based on a condition, and that condition is computed based on some registers. You'll see a little bit of variation in terminology between different instruction set architectures as to what they call branches and what they call jumps. But in RISC-V, a jump is unconditional and a branch is conditional. So we have various instructions over here. We have branch equal, branch not equal, branch less than, greater than, less than, or less than unsigned, and greater than unsigned. So each of these is going to take the branch based on the particular condition, and this condition is an operation on the two source registers. So for branch equal, if the source register 1 is equal to source register 2, then you are going to take the branch. And similarly for these other expressions. Comparison of bit ranges in Verilog by default is an unsigned operation. So the signed comparisons are the unnatural ones. We have to deal with the upper bit, which is the signed bit of the number, especially. And these expressions will take care of the signed nature of the comparisons. So step 1 here is to code all these conditions into an expression for taken branch to tell us whether we're going to take this branch or not. And the taken branch expression should also incorporate the fact that this is indeed a branch instruction. So this taken branch signal should be, this is a branch and it is taken. And we already have a signal to tell us whether this is a branch. In fact, B-type instructions are branch instructions, all of them. So you can just use is B-type, the is B-type signal that we created earlier, as the is this instruction a branch, and then provide this instruction based on the instruction D code telling us which of the instructions this might be or not. And you can use a ternary expression for that, as we've done in the past. So based on the is branch whatever, and you can default that to 0 for non-branch instructions to make sure they're not taken. And actually, I guess you don't even need the is B type if you're looking explicitly for these branch instruction types. All right, so after you've coded that, we'll come back and finish up support for branches. In the meantime, confirm that your sandbox is still saving properly, and come back when you're ready.